This conference will now be recorded.
Yeah. So today we'll be learning about NumPy library. So NumPy library has many applications, especially when you have to deal with a lot of data and which is specifically numerical. It has it is similar to your list but has many different applications and hence has many different functions which can be used. So it is also very different in case of computation with respect to in comparison to list. So first we'll see about the creation of a NumPy array. So we have a library named as NumPy, and this import NumPy as NP means that we are giving it an alias. So whatever functionalities from the library NumPy will be using, we'll have to either write it by writing the code like NumPy dot function name. So I just gave it a simple alias NP. Therefore, I could simply write it like NP dot the function name. So let's head on to the first topic, which will be our array creation. So we can create an array from the function named as arange. So like in list, we had the function name range, and as we have already discussed, we could generate a list out of it, in which the first element is inclusive and the last one is not. And the third parameter which we are giving here is the step, that how much incremental you want. Similarly, we have arange function in NumPy. So as you can see, I made use of arange function by writing np.arange. And okay, sorry, I did not execute it this line. Yeah. So I got my NumPy array here. So even in printing, you can see it's different to the list. It does not have any uh, commas separated, but it's just for representation. It is not that it is just one value. So we can also create a NumPy array using a list as well. So suppose I have this list and the contents of this list are these. So I can just make use of the function np.array and input a list to it. And then I will get an array created from it. So this is my array from this list. Now I already told you that list can be of different dimensions. Similarly, your NumPy arrays can be of different dimensions as well. So here I'm showing you a 2D list, and a NumPy array is different to a list because it will only accept homogeneous data. So by that I mean that in list, as I already had discussed earlier, that it can accept a number, a string, or even another list as an element, right? But this is not the case for NumPy arrays. It will take only one type of data. And usually we take numerical data because many of the functionalities are specifically made for that. So the discussion on today's topic would be mostly of NumPy arrays which are of numerical data, but I'll show you how to have a character array as well. So suppose I have this list and I try to print this, then I get an error here because if with the homogeneous data, the number of data should also match in it. So here you can see that there is only one element present here, but in the last one I have three elements. So that should also be similar. Now, if I try to print this, I'll get it as a list only. So you can see it did not create any array as earlier shown here. and we have these as list elements only, and you can even check the type of it, which is similar to a list. So this is why the same type of data and the number of data for each row and column matters for a NumPy. So as you can see here, we have the number of data and the nature of data, or you can see the type of data same. So this is our list, and the array created from it is this. So you can see that it is printed in a matrix form, since it is a 2D matrix. And you can also see that the type is numpy.nd array. So nd just means n dimensional, because you can have many dimensional data here. So this is the difference between a major difference between list and NumPy. And when we go through the functionalities, I'll let you know about the other differences as well. So if you have any doubt, you can ask me right now in the chat. Okay, if so, we should carry on then. So here I have a 2D list which has numerical data and string data as well. Yeah, NumPy is a package in Python, and after installing Python, you generally don't get it installed, so you'll have to explicitly install it. But it is very easy to install it explicitly only because in Python we have pip Python package manager, through which you can easily install it using a command called as pip install numpy. So yeah, so here we have numerical data as well as string data. So let's see what happens here. So this is our list which has numerical and string data. Now I'm creating an array out of it. So as you can see, it created an array out of it. And even if I check the type, I'll get the type as numpy.nd array. So what it did is it converted the complete data into string, and that's why it maintained the homogeneity. So whenever you have a mix of numerical and string data, it would prefer towards the string, and it would typecast all the data to string. So that's why a NumPy array is always homogeneous. Now, if you have any doubt, you can ask regarding this as well. Otherwise, I'll just explain you about how to have a character array, and then we'll move on ahead with the numerical NumPy arrays. Okay. So for creating a character array, we have a function called as char array. So here what you defined is the size which you want. 3,3 size basically means uh, a matrix of 3 by 3. So in maths you have studied about matrices. So this is just basically specifying what is the dimension of the array which I want. Yeah. If we have a question, why we prefer NumPy over list? Yeah, so as already discussed here about the homogeneity, there will be various other differences while we go through the course, and you'll know about what are the other uh, cases where NumPy is preferred. So as we go through the course, you'll get to know the differences and also why we prefer NumPy over list. So here I have created a character array of 3 by 3 matrix size, and this functionality, yeah, as NumPy also supports your slicing as it is supported in list as well. So here I'm basically giving the value to the array. So here you can see that it only took one character because it is a character array, right? So it only took the first letter present in this string. So there is basically no difference between the two outputs. Now to give us bigger size, we have a parameter called as item size. So I gave a value as 5 here. And now if I create a character array, I would get the result which I wanted. But yes, if I again try to give it a bigger string, it would only accept the size 5. It won't go beyond that. So this is a basic character array. Now some other ways through which we can get our NumPy arrays. So as you would have studied in while studying matrices, that we have an identity matrix, we have a zero matrix, which are usually used during different matrix operations. And identity matrix is very important while multiplication of matrices. So we can create it in NumPy as well using the function np.zeros. So here 4 meant the size. So it created a single dimension array of size 4. We can give it another size. So here it created a 2 by 2 matrix. Oh, sorry, a 4 by 4 matrix of zeros. Similarly, we can have an identity matrix. So here we have identity matrix of size 5. So here we'll only be giving a single parameter because identity is already a matrix. So it's always equal in row and column. And then we have some other functions as well, which is your linspace. So what it does is it will create an array with equally spaced numbers ranging from 0 to 100. So this last parameter is giving me how many numbers do I want in my array, and this is the range from which the numbers should be taken. So here it created equally spaced numbers. I can give it other numbers as well, and I can get the result. So these are some of the predefined functions which comes handy when we want equally spaced numbers, or we want to make use of an identity matrix, or even we can generate random numbers. So this is one function np.random.rand which created random numbers for r ranging from 0 to 1, and these numbers follow uniform distribution. We have another way of creating random numbers using normal distribution as shown here. So np.random.rand n creates it in normal distribution. And okay, can you repeat linspace? Yeah, sure. So what linspace does it, I gave it a parameter 0, 100. So similar to you can say accessing of data, 0 is the first element and 100 is the last element. So this is the range which I have given it, and here 0 and 100 both are inclusive. So you should not be confused when we are creating an array using your a range or creating a list using range. Okay, so here 0 and 100 are inclusive, and then I gave the third parameter, which actually is the parameter deciding how many numbers do I want. So linspace will give me 4 numbers ranging from 0 to 100 which are equally spaced. So you can see that 0 to 33.33 has a difference of 33.33. Then again similar second element to third element has same difference, and 166.666 has again the same difference. So this is what I meant by equally spaced numbers. And for easier, I'll change it to 5. So here you can see that 25 difference we have, here 25 difference, 25 difference, and 25 difference. So this is what I meant by equally spaced numbers. Yeah. And finally, we have another function named as np.random.randint. So here it will create any function between the range which I'm giving. And again, the last parameter is specifying how many numbers I want, which are randomly generated. So these are the basic functions through which you can get some different types of NumPy arrays created. So I'll be heading out on to the next topic, operations. If you guys have any doubts, you can ask me right now. Okay, so we can compute many operations in NumPy, and we have simple operations as well, and some specifically designed for mathematical, I mean higher mathematical operations as well. So here I just created a NumPy array using arange, and here I'm doing an operation which is adding 5 to the array. So I'll just show you what the difference would come out. So while I perform this operation, what it did is it added 5 to each element of the array. So 1 got added with 5, 2 plus 5, 3 plus 5, and then the result was generated. Okay, so this is what a NumPy operation does for addition, in contrast to what a list does. So in list, as we had discussed, addition would just do concatenation. So here I had two lists. I tried to add it. So what it did is it's concatenated the elements and created one single list out of it. And yes, I cannot add one element to a list, because this would give me an error saying that can only catenate list, not integer. So this is a difference, a major difference between a list and an array, because many times you have to do computations like for example, if you have a NumPy array of salaries of an employee, of various employees of an organization, and you want to calculate uh, maybe the basic salary or whatever it is, or you want to give an increment, equal increment to all the employees. So you can basically just make use of this function, and it would reflect to each element of that array, which would have been difficult while using list, because then we would have made use of an iteration like for loop or while loop to do so. Yeah, I'll move on to array 2 as well. So here I was trying to create another array. So this is an array ARR2, and I'll just name it 1 maybe, and I'm creating another array ARR2. Okay, so as I already showed you that here list, when they are added with another list, it computes a concatenation function. So here you can add different arrays as well, not just a single value to an array. You can add different arrays as well, but there is one thing which you must take care of, that the size of the arrays must be same. So here it gave me an error saying that the shape is 9 and 10. So here the number of elements were 9, and here they were 10. So if I just make them equal, then adding them would not give me an error. Okay, just a second. Yeah. So here I got my result, which is just the addition of two arrays. 10 got added with 10. I'll just show you that. Just comment this out. Yeah. So this was my first array, this was my second array. Since the number of elements, as you can see, are equal, element-wise addition for that array happened. So this element got added with this element got added with this, and similarly to the respective indexes, the elements got added up. And if I change the size, then you can see that I got an error depicting the inequality of the shapes. So you can see there is one element less here, and that's why the error which we got there. So I hope I was able to clear your doubt. If anyone has any other doubt, they can ask me. Otherwise, we'll head on to the other topic. Okay, so now I'll show you some different operations. I mean, the basic mathematical operations which we can do on NumPy, which is your addition, subtraction, division. So here I've shown you the addition. If I simply replace it with a subtraction mark, it would calculate subtraction. So addition and subtraction do not have much of a difference, but the one which I would like to show you would be the division and multiplication. So here I've created a NumPy array with these elements 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, and I'm creating another array with these elements. Okay, so if I want to compute any calculation between these two arrays, the first thing is that their number of elements should be same. So here I'm computing the multiplication between them. So again, they did element wise multiplication. So 0 with 0, 2 with 10, 4 with 20, and similarly 18 with 90. And I got this answer as the output. Now I can even do division here. So 0 got divided by 0. So that's why I got an NaN present here. So a benefit was that NumPy handled the value which does not have any output. So 0 by 0 is something which we cannot compute, and that's why it gave it as an NaN. And it did not give us an error which we usually get while computing. So here, as you can see, usually we get a zero division error, but in NumPy calculation, it made use of an NaN variable. And similarly, your 10 got divided, 20 got divided by 4, 10 got divided by 2, and that's why we got the answer 5, because the divisions are giving the same answer. So now we can also check this again. We can divide the arrays other way as well, and we got the answer again as that. Now here I am giving that output to a new variable named as s. So I'm saving that output to a variable s, and I'll print that variable s. So this is what my output is. Now, if I want to check whether which element is NaN, so this is one of the types which I can use. But if we look into it, then you'll see that it is giving me a false, because for NaNs, NumPy does not actually give true when checked using np.nan. So there's another way through which we can check it, which is np.isNaN. And then we can give the element which we want to check for, and it gave us a true sign. So this is one thing we should keep in mind. np.nan will always give us false as an answer. So this is one problem of NaN. But there's another problem which we usually face is the division by 0. So if the upper number is not 0 but the lower one is, so here I'll create another array for which the numbers 0 is not present, and the second array has a number 0. So multiplication did not have any problem, and dividing the second array with the first one also did not have any problem, because 0 by anything except 0 is not going to cause any problem in mathematical terms. But now I'm dividing the first array by the second one. So I got inf, infinity defined here. And again, I did not get any error. So as you can see, by element wise division, 1 divided by 0 had occurred here. So normally I would get an error division by 0 here. but in case of array computation I did not get. And similarly I can save that to an array, and I can check whether that element present is an infinite number or not. So this is one of the ways for checking it. And another way is using np.inf. So here you can use both of the ways for checking an infinite number, which is basically if the number has 0 as a divisor. But in np.nan you have to make sure that you make use of np.isnan. So any questions regarding this? Okay, so I have a question that if NumPy is not available, then how to install it? Okay, so I'll just show you how to do that as well. So after installing Python, the first thing is that you must check the version. So by using this command, I actually got to know the version of Python installed on my PC and also whether the Python home variable was set up or not. Otherwise, it would have given me a command not found error. Now Python has its own package manager called as pip. So I need to check whether it is installed or not. This package manager usually gets installed with Python itself. So I can know that where it is installed. Sorry. Yeah. So now we can make use of pip to install any package simply using a command pip install numpy. So it will try to check first in your Python packages whether it is present or not. If it is present, it will give you a notification that requirement already satisfied. Otherwise, it will start installing the package. So if I give any different package, like maybe Flask, okay, that is also installed. Yeah, suppose I gave a package which is not present in my library. So you can see that it has started downloading it from the internet from the following link here, written here. So after it downloads it, it will start installing it, and then you can just simply import it in your project and start using it right away. There is nothing else which you need to do. So let's start with other operations which are present for NumPy arrays. So suppose I have these two arrays present. One is a single array, a single dimensional array, and another one is a two-dimensional array. So we have a property called as dtype, which tells us what is the type of the array which we created. So since all the elements were integer, it gave us the output as int32. There is another function called as np.result_type, which can be used to get the result. So both of them gives us the same result. And similarly, we can do the same for a two-dimensional array as well. And since the elements are same, we got the type as same. How to add one element of a list to a list of list. I'm actually, can you give some details regarding your question? Because I could not understand your question. Okay, you have a list and another you have a list of list. Is it possible to add both? Okay, so according to my understanding, what you're saying is you have this, right? And then you have another list, and you want to know what would happen if I add them, right? Is this what you want? Yeah. So I've already told you that in list, addition means concatenation. So you can see that the resultant is another list in which the first elements of the list 1 lst is present, and then the list element of list 2 are added here. By list element I mean that this is a 2D list, but we can have another way of visualizing it, that the first element of list 2 is a list and the second element of list 2 is a list. So that is why this got added as a complete element and this got added as another element here. So this created a third list for us. Okay, yeah. So this was a little bit about list. Let's head back to our NumPy arrays. So yes, so it gave us the data type depending upon the data which was present here, right? So suppose I make it string. So let's see what data type it will take now. So as you can see, it is giving an output like U11. So this usually means Unicode. So in for strings, Unicode is one of the ways of storing strings, because Unicode supports a lot of characters unlike ASCII, and that's why it took the data type as Unicode to conserve the homogeneity of the complete array, as I've already mentioned in our first topic which we were discussing about. So now if I want to give another data type to my array, so we have a parameter called as d type, and I can give any type which I want to give it as. So here I gave it a type as np.float64. So float, I converted all the values to float, and you can see while printing it, I got 1 dot, 2 dot, 3 dot, 4 dot. So this is basically float type basically supports floating type integers, right? It has a decimal part. So that's why the dot was present here. And yeah, so if you have any doubts regarding this, you can ask me. Okay, so suppose, okay, we have one question. Can we also add heterogeneous data to list? Yes, your list can absolutely have heterogeneous data. So I'll head back to the example which I had discussed right now. Now see, this is string data, completely string data, and this is a list of list. And the base value present here are all numeric values. So if I compute that, then you can see I'm getting a string value and your list elements, and I can also add single elements. See, so I got my numeric values, I got a list as an element, I also got a string as an element. Okay, so this is what heterogeneous data means, but in NumPy array, the data must be homogeneous. Yeah. Minakshi, which part do you want me to repeat? I would repeat that. Okay, okay. Yeah, so as I already told you that here, all the data is numeric. See, it has integer values, right? So the data type it took out implicitly. I mean, by seeing the data, it decided that this would be integer 32. And I had already shown you that here when the data was string, it changed the type to Unicode 11, which for your easiness, you can consider it that it converted it to string data type. So this is what I was telling about choosing the data type. But if I want to explicitly give a data type to an array, so while creating that array, I have, like similarly here I have created an array. I can give an extra parameter known as d type, and here I can specify what type I want to give out. So this is one of the type which NumPy supports, and float type. So I wrote np.float64, and that's why the output which I got was 1.5 in this. And yeah, so if I print the d type of it, see, I would get float64 as the output here. So this is what I meant by giving it a data type explicitly. Here I could have given it other data as well, like this, and then it would have converted it to float64. So this is your implicit typecasting, and this is your explicit one, in which I want to forcefully give it a single type of data. So this is the difference between the two. And yeah, so we were here. We suppose we have an array, simple array having numbers 1 to 5. Now NumPy has another function called as append, similar to the append function which we had in list, if you guys remember. So what it will do, it will add this element to the array present here. So this array has all numerical data. I'm adding a string to it, and the new array which will be generated will be saved in this arr new variable. So let's see what the output comes out to be. So I already told you that NumPy arrays keep homogeneous data. So because of the string which was appended to the array, it converted all of the elements to the string as well, and you can see that the d type is Unicode. Yeah. So apart from d type, there is another function called as shape, which tells us the dimensions of the array which we have. So here our first array was a single dimensional array. So and the number of elements are 5 here. So it gave us a 5 comma, depicting that it is a single dimensional array with 5 elements present in it. And similarly, this is a 2D array. So it got printed as a matrix, and here it is giving me the number of elements present. So by this, it means that there are 2 rows and 6 columns. As you can see here, 2 rows and 6 columns present here. So this is what shape means, and this is also what we were getting as an error. If you guys remember that when we were trying to do computations, uh, I'll just head on to that example again. Yeah, the example here, if you remember, it was giving us an error: operands could not broadcast together with shapes 10 and 9. So this is what it meant with shape, that the dimensions are not matching. So this has a size of 10 and this has a size of 9, and that's why we were getting that error. So just keep in mind that it checks the shape. So not only the number of elements, but the you can say the dimensions should also match when you are performing. So it is just similar to your matrix operations, because in matrix operations also the number of rows and columns both should match, right? So similarly, this is a representation of matrix here as NumPy array. So at last we have another function called as reshape. So here I have a matrix 2 by 6 which has 2 rows and 6 columns. Now I can reshape it to another dimension, which is I'm converting it to a 6 by 2 matrix. The reshape function can be used here. Okay, it just gave me an error. So my ARR2 had 2 rows and 6 elements, so 2 by 6, and I converted it. I basically did a transpose of it, and now I have 2 columns and 6 rows. So you just have seen that I got one of the errors here, because if I try to reshape it in a way in which all of the elements would not fit, then I would get this error that cannot reshape array of size 12 into shape 5 by 2, because 5 by 2 would be able to accommodate your 10, 10 elements, but for 12 elements you need to have something like 6 by 2 or 4 by 3. So here you got an array of 4 by 3, which is keeping all your 12 elements present here. So this is all about reshape and shape and dtype. So if you guys have any questions, you can ask me. Otherwise, we'll head on to the next topic. Okay. So the topic now is other NumPy operations, which is basically one of the most used features of NumPy. So here again, I have a 1D array and a 2D array. So NumPy has a function called as max, which would basically give me the maximum element present in that array. So if I use it on a 2D array, I would get the output out of all the elements present in that array. And yes, in a 2D array, I can have the answer on the basis of rows as well. So as you can see, let me just print the array first so that you can have a better representation. Yeah, so this was my array, and on doing array2.max, I got 12 as the output, which is out of the complete array, and ARR2 0 max gave me the maximum element of the first row. Similarly, I can have the output for the second row as well, which is 12. So this is useful when we want to have computations on basis of rows. And similarly, we have the min function, which would give me the minimum value present in that array. And again, you can do it row wise for multi-dimensional array, and for single dimensional array, a single output you can get. And now we have other functions called as argmin and argmax. So at times you want to know not what the maximum element is, but at what position it is present. So this is what these functions would give us the output as. So if I use it here for first array, so here, so it returned an output as 0 and 4. So it basically means the index where it is present. So at 0th index, I have the minimum value present, and at 4th index, so 0, 1, 2, 3, 4. So at fourth index means the fifth position, I have the maximum element present, and I can even access it through my slicing. So here, yeah. So here I got the output of the maximum element present in my array. And similarly, I can have the output of my minimum element as well. So this is about the maximum minimum for a single dimensional array. Now suppose I have a two-dimensional array. So what would the outputs would be? So here I got the outputs at 0 and 11. But if I try to access it, it would give me an error. right? Just make use of this. Yeah, it's giving me an error because it is a 2D array, so it would require a row and a column value. But what it's giving me, I'll let you know what it is. So by 0, it means the 0th index, which is basically the first position. And by 11, it means the element at 11th index, or you can consider 12th position. So this is the first position, this is the sixth position, and you can see that this is the 12th position. So the maximum element is present at 12th position, but I cannot access it using this function for a n-dimensional array. For a single dimensional array, it worked fine. So there are ways through which we can do. Firstly, we can have certain computation to know what exactly would 11 mean. So for a 2D array, I can calculate it easily that it is obviously going to be 1 comma 5 because I know that I have two rows and 6 elements each. So this would give me the output. But there are many times when we cannot compute just by knowing this. So there is one way is the using of a function called as unravel underscore index. So here what it does is it will take the argument, which is the shape, and the maximum argmax, which is just this index position, and it would calculate it for us. So basically this what we were doing using our own calculation, we have a function present for it, and then it can give us the dimension 1 comma 5. And as I have already printed it earlier, we can similarly print it here as well. So I got the value as 12 present, right? Now there is another way to get it, which is even more easier, and it uses only one function, which is where function. So NumPy has a where function in which you must give a condition. So here I'm giving a condition that in array 2, the element which is equal to the maximum element present in array 2. So that element I need to print. So let's go step by step on this. At first, I'll print this. Yeah, sorry everyone. Yeah, so np.array, it looked for the position or the indexes where that max element is present in ARR2. So I got an output as array1 dtype, array another 2 dtype. So this basically means the first index and the second index. So basically a row and column. So if we would have had a three-dimensional array, then there would have been another array element present here, which would give us the third dimensional value for the maximum element present in our array. And if we have this value, then obviously we can print the maximum value present here. So as you can see, we got the value printed here as array 12. So this is another way for getting your maximum value present or minimum value present. Uh, Apart from these, we have other functions as well. Your important higher mathematical operations like your square root, which is np.sqrt function. You can create log of it. You can have exponential to it, and this is basically e to the power of all the elements of the array. You can have a sine of it. You can have cos of it. You can have the tangent of it as well. So here are all the calculations for it. Okay. And if any of the values are 0 by 0 or 1 by 0, then I think you already know what the output would be, NaN and INF. So which usually comes when you're doing log. So that's why any operation which is done in NumPy array for numerical data will always give some of the outputs, but we must always keep in mind when we have certain numerical data which can give us an output as infinite or an NaN, which is basically 0 by 0. So any doubt till here? After this, we have just last topic, indexing, left. So you can ask me if you have any doubts. Okay, so this is the last topic, indexing. So just like in list, we could make use of slices. Similarly, we can make use of slices in arrays as well. So this is basically just your 0 to 2. Here 2 is not inclusive. So just remember that it would take out the elements present at index 0 and index 1. By index 0 and index 1, I mean position 1 and position 2. So that's why 1 and 2 got printed here. Now I can even make use of these slices to give or change the data present in that array. So here I gave for arrays position 1 and 2 to be given the value 0, and that's why if I print the whole array, you can see that the first two elements got changed to 0. Now if I want to keep the copy of this original copy of this present, and I want to make computations, but I want to also keep the original safe with me. So we have a copy function present. So here I'll create an array, then I'll grant the copy of it to another variable and then do the operations. So here array 1 was created with the numbers, its copy was sent to ARR, and then I made some changes in the data of ARR. So here ARR is having the changed data, but my ARR1 is having the original data present. So this is also useful when I want to have the old and the changed data both with me. Maybe I want to do some comparison, or maybe I want to just show the difference between, like, so in some cases when we want to show that this was the old data and this is the new data, something of that sort. So yeah, and this is for 1D array. So now I have a 2D, I have two-dimensional array. So this is my two-dimensional array. So here also I can make use of indexes, but I need to keep in mind that it is for a two-dimensional array, it is a matrix. So here I have 4 rows and 6 columns. So by ARR2 2, I mean position 3 and 3. So index is 2, 0, 1, 2. Okay, and the column is also 2. So here I'll just write it out that it is a row comma column, and these values are the indexes. So 0, 1, 2, and column index is 0, 1, 2, and that's why 4 got printed here. So keep in mind that indexes are given here, and instead of just getting a single output, I can also have output in the form of just a row I want to get printed out. So 0, 1, 2. So that's why the third row but present at index 2 got printed here, and I can also give it as a range if I want a range of rows printed. So this is basically 2 and 3, and I can also have a range of columns which I want to be printed. So for that I can make use of uh, your range present in the column index as well. And I mean, you can do various other operations as well. and I would leave this to for self-learning, because there are various combinations which you can make for rows and columns. And if you have a more dimensional array, then the complexity would increase. So this is all subject to self-learning. Now, beside this, you can also have certain computations, like you want to know the elements which are greater than 3. So this is my simple single dimensional array, and I want to know what are the elements which are greater than 3 present here. So when I wrote this condition, I got an array which is in Boolean form. So it is giving me an answer false, 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 true, true. So what it is giving me an answer is that the element present at these positions have satisfied the condition, and the elements present at these positions have not satisfied the condition. But I want to know the element which are satisfying the condition. I don't want to have this, you can say, Boolean matrix. So I make use of, again, indexing your uh, for the single dimensional array, and while printing it, I got my answer that the last two elements, which was 4 and 5, satisfy this condition, and that's why they got printed. Now, as discussed earlier, we have np.where as well, which takes a condition as an input. So using np.array as well, you can do the same, and then you can print the output as well. Okay, so you got the same output while using np.array as well. So this is a basic understanding about NumPy array. There is another thing which might look bizarre, but you can actually give a condition of one array to another array, because a Boolean matrix is created. So that's why the last two elements of this array got printed here. So I just wanted to mention this, but yeah, I won't explain much about this. This is just self-study. So yeah, that's all from my side. If you have any questions, you can ask me, or else we can end the session. Okay. Thank you, everyone. Um, Goodbye.